Hi. So we're going to finish these examples of probabilities using combinations with some examples of poker. So hands of poker. So we're going to assume that we know a little bit of poker. We're going to explain the basics, but we use a standard deck of cards that we call them, these are spades, clubs, diamonds, and hearts. And for each of these, you have 13 cards, the ace, and then numbers from 2 to 10, and then a jack, a queen, and a king. So you have a total of 52 cards, and 5 cards are given to a player. And of course, the idea is to get 2 of a kind or 3 of a kind, and so on. So I want to start, for some reason, I think this is the easiest to do to find a probability of finding a full house. So a full house means that it's full house because all 5 cards that were given to you are occupied. 3 are the same denomination, which means, for example, I could have gotten 3, let me pick a color here, 3 sixes, and the other 2 are a pair. So they're a pair of queens, for example. So that would be a full house, 3 of a kind, and a pair. Okay, so what's the probability that when you give you 5 cards, we shuffle the cards, you get a full house? So I'm going to delete these for a minute, but so how do we do this? It's weird that we start here and not with a pair, because this, I think, is the easiest example. Everything is occupied, and that makes it the mindset a little bit different. So I'm going to select, I have I have a 3 of a kind and a pair. So first of all, let's just find out how many total possible hands of poker are there. And that would be my denominator, right, of the probability. So the probability is always dividing 2 quantities. In the numerator, I'm dividing how many favorable outcomes. So the numerator is going to be how many ways can I get 3 of a full house. And in the denominator is going to be how many possible total ways can you get 5 cards from a deck of 52. And that's exactly 52C5, right? That's what it means to pick 5 objects from a group of 52. The order doesn't matter, because if you give 5 cards in poker, the order in which they were given to you doesn't matter. You're going to shuffle them to have it in the order you want to see them. And it's only get 1 card once, of course. There's no repetitions. And so that's why it's a combination. Now, in the numerator, I'm going to pick the 3 of a kind, okay? So I'm going to do, with this color, the 3 cards of 1 denomination. We call it 3 of a kind. So I don't know which first, I don't know what, when I drew it, when I showed you, I was 3 sixes. Well, it could have been 3 sixes, but I don't really know where is it, right? I need to pick a row. So it could have been 3 aces, or 3 fives, or 3 tens, or 3 fours, or 3 Ks, right? I don't know which row to go. So I have 13 rows down. I like to do it that way. I'm going to pick 1 row. So I'm going to write that like 13C1. Okay, pretend I do from 13 options, I pick 1, and I landed on the 5, I don't know. So, but I did that by doing 13C1. I'm going to write out here, right here like 13C1. Once you pick the row, now I still have something to choose, right? Now I'm going to choose from the 4 cards that I have there, I'm going to pick 3, right? I'm not going to use all of them. I'm only going to pick 3 of them. Which 3? Well, I don't know. I'm just making a sketch to understand what's going on. In fact, I don't know why I changed colors. Let me change the same color. I pick 3. Yeah. So that way means that I picked from the 4 fives, or the 4 number that I had, 3 of them. So that means I'm doing 4C1. 4C3, sorry. It's a 4C3 because 4C3 and 4C1 are the same, because you're picking one who's not there, right? But anyway, so 13C1 times 4C3, multiply these, of course, because we're counting. This gives you the 3 of a kind. So I'm going to read little notes here. This number came, my bubble is there, so I'm going to write there. So let me move my bubble somewhere over here. I don't need that anymore. So this comes from choose denomination or number. Choose denomination, that means the number, right, of for 3 of a kind. And then here I'm choosing the suits for 3 of a kind. Okay, so that way I picked my 3 of a kind. Now I have to repeat the same process for the pair. Right, so now I'm going to go the same reasoning. I don't know which pair I'm going to use, so this is too thick. Let me erase that. So I'm going to pick, I don't know which one, and again, it could have been this one, that one. All I know is that it can't be the one I chose, right? So I don't have 13 now to choose. I only have 12, right? So I'm going to pick 12, and I'm going to say from 12, I'm going to reduce this one in red, 12C1 to pick which is the number or the denomination I'm going to use for the 3 of a kind. But once you picked it, then I'm going to go across and pick 2, right? From 4 possible. So that means it's 4C2. And if we want to complete this notes, this is, I'm going to instead of choose, it's easier to right pick denomination for the pair. And this came from pick the suits for the pair. Okay, so there you go. This is what you do to find a full house. So 13C1 is a 13, 4C3 is 4, 12C1 is 12. Another one that you really need to calculate is 4C2. That's 4 times 3 divided by 2, so it's a 6. So all those numbers in the numerator are very easy to calculate. So I'm saying that because when you go to the calculator, and I'm going to use class calc for this, like I've been using, I really don't have to type the whole thing. Like if you do, remember you can type here in your calculator, in your computer, NCR, and I can do 13C1. I know that's a 13 because you're only picking 1 from the 13. The other factor I had was 4C3. Why did I know that that's, 4C1 is the same as 4C3? Because that's a property of combinations that whenever you pick a subset, it's the same as choosing who you are not picking. So, for example, 5C2 is the same as 5C3. Yeah? 10C8 is the same as 10C2, because if you pick 8 out of 10, it's the same as selecting which of the 2 that you didn't select. So that's a shortcut. So 4C3 is 4. The other one I had was 12C1, so of course that's a 12. I'm just doing this to show you why I said that very quickly. And the last one was 4C2. So 4C2 I said was 6 because that's the only one that had to do something. It's 4 times 3 divided by 2 factorial, so it's 2, so it's 6. So and all that to write that the numbers that look very ugly here, yeah, and I can write them very easily on the numerator. It's just 13 times 4 times 12 times 6. And then my denominator, I don't have to write them. I'll write all denominator the same thing. This I do the NCR, and I do the 52C5. Okay. Now it's written everything like that, but it doesn't matter, right? If I have them all in the parentheses here, it doesn't matter that it's written like that, right? I could put them in the denominator, so I could write 13 times 4 times 12. Times 6. Okay, so my answer is less than 1%, 0.00144. I'm going to use 5 decimals for these. Okay, let's go to my next example. So I'm going to do now the same logic, but I'm going to do 2 pairs. Okay, now you've noticed that here I kind of said that I picked first the denomination for 3 of a kind. There was 13 to choose that one from. Then I did the 12 once I already picked which is a 3 of a kind. For the next one, because I'm doing 2 pairs, and they are at the same level, right? It doesn't distinction which one is. When you do a full house, you say, I have a full house of 6s and 5s. The order matters. I'm kind of implying that the 6s are the one you have a 3 of a kind, right? But if I tell you I have 2 pairs of 5s and 10s, it doesn't matter. Both of them are pairs. So because they're at the same level, first I need to choose which are the 2 denominations for which I'm going to have the 2 pairs, because they're at the same level, in 2 pairs. So that's the first thing. So I need to first choose from 13, choose 2 denominations for the pairs. Okay, you don't first choose one and then say from the 12 that are left over choose the second one, because that implies there's an order for which is the one and for is the second. There is no order if you have 2 pairs of 7s and 8s. Yeah, so that's why I said that the full house is a little bit easier or easier to follow. For the 2 pairs, there are the denominations of the pairs are at the same level, so you choose them at the beginning. Okay, so 13 choose 2, and right here I picked denomination for 2 pairs. Okay, now once I know it's going to be here and here, I go across and I pick a pair from there and a pair from here, right? And I have to do 4C2 for each of those. So I'm going to have a 4C2 for the first one and a 4C2 for the other. And this is picking 2 suits for first pair, or 1 pairs, right? It did have no order. And here I'm picking 2 suits for a second pair. I just wrote first and second pair because that's how we talk, but there is no order, right? They're both at the same level. That's the point. Okay, so there I got my 4, and then I divide by 52C5. If you think that's right, you're almost right. Something is missing, because the other thing that's complicated about this one versus the other one is that I haven't used all the cards yet. Yeah, and the full house, all the cards were occupied, so when I did the 3 and the 2, it's done. But here, so far, I have only picked 4 cards, right? 2 for my first pair and 2 for the second pair. I still have to pick 1 more card, right? And that 1 more card, the restriction is that it cannot be either of those 2 pairs. Sorry, either of those 2 numbers that we already use for the pairs. Because if you're never going to say, I have 2 pairs, a pair of 3s, a pair of 7s. Oh, and by the way, my 5th card is also a 7. No, that 5th card, if you have that, that's counted as a full house. So your 5th card cannot be one of those, so it has to be chosen from the other ones. So to keep the same order, the same logic that I've been doing in these 2 examples, I want to say, well, now let's pick, I have to pick 1 denomination from the other ones, right? How many do I have? I have 11 because 2 are occupied, right? So I have 11 to choose from. So it's 11, choose 1. And once it's chosen, then you go across and I select 1 of them, right? So that would be done by doing 11C1 to pick which denomination, and once you picked it, now go across, and it's 4C1 to pick the suit. So I'm going to write a little note here for completeness. Pick denomination for 5th card. It's hard to write small with my big thick tip of my pencil, and I'm going to write here, pick suit of 5th card. Okay, hope that makes sense. There's another way. This last part, what is in red, I could have done it easily and say I'm going to pick 1 card that are not in these 2 rows, right? So how many cards are not in those two rows? There's total 52 cards. Eliminate those 8, you get 44 cards. So it's 44C1, right? And 44C1 is just a 44, so I could have just written a 44C1 or a 44 there for this factor. But this is also that. Why? Because, like I said before, 11C1 is 11, and 4C1 is 4, so 11 times 4 is a 44. So it's easier to write 44C1 or just type the 44 there, but because I'm going down by rows and then by columns, I think it makes more sense to keep that system, and it still works for this. Okay, so let's find what's the probability for this. It's and these numbers are also, a lot of them are easy. The 13C2, this is the only one I need to calculate, because 4C2 I know is a 6, right? We did it before. 11C1 is an 11, and 4C1 is a 4. In fact, those two together are a 44. So the only one I really need to do is 13C2, which is 13 times 12 divided by 2. So it's 13 times 6, which is not hard. But I mean, I just want to say these are not hard numbers, right? Though, of course, we do need to calculate the 52C5. So that would be done. So let's do it. So I'm going to type in my calculator. So the numerator is going to be changed. I'm going to leave the denominator the same as 52C5. So these numbers were, the only one I need to do is NCR for 13 with a 2. Then I said I'm multiplying times a 6 times a 6 times a 44, right? Or times 11 times 4. So it's about 475. And I like to bring this example up a lot, 475. Or 475, yeah. I like to bring this example a lot because for many things in probability or in statistics later on, we use a cutoff of a 5% probability. And we say, if it's less than 5%, we're going to say, well, it's unlikely to happen. If something happens only 5% of the time or less, it's not very usual, so it cannot happen. This is the cutoff that we use a lot for the p-value for the test later on. And maybe you guys have seen it or heard about why it's 5% is the cutoff. It's almost, and sometimes we lose track of what is a 5% probability. Things are, is it really that uncommon to happen? And this is a very tangible example, yeah, that you can see. If you have any experience with cards, playing poker, I give you 5 cards. Is it unlikely that I give you 2 pairs? Yes, it is. But if you play poker a few times, it has happened. Right? That you get 5 cards, you pick it up, and you got 2 pairs. Okay, so it's a good example to keep in the back of your head of saying, oh, that's something that has probability 5%, like getting 2 pairs in the poker game. Okay, I'm going to do one last example. This video is getting very long, but I think it makes sense to put them all in the same video. The last example is find a probability. Oh, this is covering here. Getting 1 pair. Okay, just 1 pair. So this is the hardest one that I'm going to do. It's not hard. It's just like it's weird that it's the most common or the lowest, that ones that have more probability to happen. But it's not the easiest to calculate, right? Like I said before, the full house was the easiest because all the cards are occupied. The 2 pairs, okay, we had to deal with a couple things. This is something like that, okay? So to deal with 1 pair, of course, there's only 1 pair, so I need to select first which pair I'm going to be using, right? So I go down here, sorry, which denomination, right? Is it going to be a pair of aces? Is it going to be a pair of 8s? Is it going to be a pair of queens or kings? So of course, first thing we know now, it's 13C1, right? So 13C1 for the denomination, and I'm going to write, sorry, in the denominator, of course, it's 52C5 always. So this is picking the pair, sorry, the denomination for the pair. Once you picked it, then you pick your 2 cards, right? That's again a 4C1. So far so good. Sorry, 4C2. You're picking 2 cards. So now I'm going to pick 3 cards. That is not in that row. Right, so all I know is that I eliminate that row because I don't want the other cards. If I give you, if I say I have a pair of 6s, it means that of my other 3 cards, they are not 6s, right? So the first thing to do, or the first approach to this is think, oh, okay, so that means it cannot be any of those four. So I could do 12C. No, let me do it like this. What I'm going to say is wrong, okay? I'm just going to the wrong mindset. I eliminate those four, so I can do 48C3. That means select 3 cards that are not in that row, right? There's 52 total, so eliminate that row, so you get 3 more cards from anywhere else, and that's it. Well, this is wrong, and this is why doing a pair is more complicated, because you don't want those 3 cards to be equal among themselves. In fact, you want them to be all different, right? Because you don't want them to be equal among themselves. That would be a full house. You don't want to have a pair and the third card different. That would have been 2 pairs, right? So you have to force them to be all 3 different. So this would be incorrect. You can't choose all 3 at the same time from the 48. Oh, let me put it this way. You can't choose them all at the same level. You have to say, okay, I'm going to pick 3. You have to go by numbers and say again, which denomination are you going to choose for your other cards? Those 3 are at the same level, but you have to pick 3 numbers, right? 3 denominations. So from the 12 that are not in that row, the 3rd rows that are not that one of your pair, I'm going to select 3. This is 12C3, so the 3 denominations. And once you select them, then you pick 1 card from each of them. Yeah, and that would be a 4C1 times a 4C1 times a 4C1 for each one. And of course, this is just a 4 times 4 times 4. But again, keeping this row columns thing happening keeps things organized. So I like to write 13C1 for the pair, for the number of the or the denomination of the pair, 4C2 across to get the pair, right? That's this one, what I did here. Then 12C3 for picking the 3 that are going to be your 3 different numbers or denominations, and then a 4C1 for one of them, a 4C1 for the other one, a 4C1 for the third one. Okay, and so that's the probability of getting 1 pair. So, and all these numbers are easy, right? Well, no, sorry, 12C3 might be the hard one. So 13C1 is 13, 4C2 is 6, 12C3, that might be the hard one. It's, well, no, 12, yeah, it's 12 times 11 times 10 divided by 6. And then 4 is C factorial. Sorry, 4C1 is 4, 4C1 is 4, 4C1 is 4. So let me write them down to figure out what this is. So the denominator is the same. So let's just go, the only one I'm going to do is 13C1. Let me type them here. I had a 13. I lost track of where it was. Okay, let me write this down like this. Let me rewrite that. So I have, the only one I need to calculate is 12C3. Then I'm going to multiply by a 13 times a 6. That was the 4C2. Then I had the 12C3, which is there. Then I had a 4 and a 4 and a 4. Yeah. 12C3, 13C1, 13, 12C3, which is the 4C2, and 3 4s. Yeah, so it's 42%. So about 42% of the time, if you get 2, 6. If you're dealt 5 cards, you will get a pair. Okay, so it's not that uncommon to get a pair when you play poker. Okay, so those are my examples for doing probabilities with combinations and the poker applications.